Cool. So my name's Joel Paulino. I'm a lead software engineer here at ServiceTitan. Been here for about a year and some change. Before that, I had my own startup and worked at various startups, dev shops. And I'm really passionate about performance. And I wanted to give this introductory presentation on what you can do today with a minimal effort to introduce performance monitoring and some small quick wins in the optimization front. So that's going to be this is sort of an introductory talk. So we're going to cover a lot of topics very lightly. And at the end, I'll recommend some further reading where you can really dive in and really dive into fixing performance issues. A little more about ServiceTitan. So ServiceTitan is the world's leading software technology platform for the trades. We're talking about field service businesses like HVAC, residential and commercial, plumbing, electrical. And here's some more information about our funding and our investors. But it's going to be, and I believe this is going to be the first software platform to power an industry end-to-end. Yeah, I'm really excited to work here. I enjoy my work. So with that said, let's get started. Performance is not load time. I hear a lot of people kind of say, oh, well, my website loads quickly, so it's performant. No, that's not necessarily true. Users deem your site as performant if they get value as soon as they expect it from your application. And that expectation is set by other sites. So if you have a competitor who's faster than you, that can be very bad for you. And so I like to think of performance as a feature. So it's a feature. Sometimes it's an underserved feature, as you'll see with some of the case studies that I point out. Because it's a feature, I put it under the realm of UX. Performance sites, if your app is perceived as performant, your users are usually happy about that. And so it's a UX win to have a performance site. And UX can easily be tied to business outcomes directly. So essentially, if you take anything from this chat, this talk, it's that performance really is perceived performance, and that deltas in performance can mean losing or gaining money, depending on which direction you go. Yeah. So sorry about that. I think I overshot. So what are the consequences of underperforming? There's a couple case studies here. I will just give you a brief summary. I think the first one is the most interesting one, because from it came a term that I've loved ever since I heard it. They did a study with EOG technology and behavior analysis, and noticed that when a user was using an underperforming site, their levels of stress went up, and they coined the term web stress. And so if you're an application that causes people web stress, if they have to use it, then you're putting people in a state of duress a lot of the time that they're using it. If you have a landing page or a marketing site, they're just going to leave. So I think that's something to take away, that there's actual implications. If people leave your marketing site before they really see what you sell, then they're not going to buy. And if people churn on your web app after using it for a couple weeks, then you're going to lose money. So that's what I mean by UX. That UX component of bad UX, which I believe performance is a part of UX, can affect the bottom line. So what are some benefits of being a a snappy website? Here's some more case studies. I got these case studies from WPO Stats. It's a great website for case studies on performance. Particularly, there's a focus on front-end performance, like in this talk. But obviously, I think there's case studies in there of optimizing database queries or adding indexes as well. So not just front-end performance, but I think the first example is a great one. AliExpress reduced load time by 30%, by 36%, and saw an increase in orders and an increase in conversion. Ancestry.com saw a 7% increase in conversion after improving the render time. So again, it's different metrics, not just load time. They also improved load time as well. But there's some tangible wins that you can achieve if you start focusing on performance. So how do we measure a perception? Well, not with surveys. Surveys don't provide any tangible ROI, so why would I do a survey to help you out? It's difficult to get a representative sample. Usually people who are highly engaged with your application probably will fill out your survey. And there's a delay in you release something, you want to see the performance. If you're relying on user surveys, you're going to ultimately have to wait until someone fills out your survey. But so how do you do it? With metrics, and we're going to go over these metrics, but you collect them silently. You can have any sample size you want, essentially. There's an immediate feedback loop, and you can have cool visualizations. This particular visualization is the correlation between bounce rate and blocking CSS and blocking JS, which I think is really cool. The tool that we're using to generate this is SpeedCurve. They have a suite of products for this sort of thing, and they actually use the APIs that I'm going to talk about. Their big value add is the visualization. So although you might not be able to get these nice visualizations today without a third party, you will be able to capture the same data that is being captured by SpeedCurve and its competitors. We're going to go over some definitions. I'm going to try to keep it light. I just don't want to read. But there's really two main approaches to performance monitoring. There's synthetic monitoring, and then there's real user monitoring. This talk is going to focus on real user monitoring. But just to give a brief definition of synthetic monitoring, I'm going to go, it says laboratory environment, but I'll give an example. Let's say you have continuous deployment built into your flow, and you want to check that certain things, there are no regressions. For example, if as a part of your monitoring, you monitor the size of your JavaScript bundles that you're creating, you can stop a deployment if the bundle size is above a threshold, or you can get a warning or get an alert. Because you're doing it in a controlled environment, you essentially are doing it in a deployment machine, running that check. That's considered synthetic. Another example would be doing some of the monitoring that I'm going to show, but again, not doing it with a real user, doing it in an automated environment. So there's a lot of metrics that you could capture with synthetic monitoring, and not just metrics, but you can have performance budgets, for example, like to measure your bundle size. But time to first byte, speed index, time to interactive, these are all synthetic measurements, metrics that we capture in our synthetic testing. Famous synthetic testing tools are Lighthouse. That's actually been integrated to the browser if you have ever used that in your Chrome DevTools. Web page test, which I believe Lighthouse is based on. It's an open source library for running a lot of these synthetic tests. And a lot of these tests rely on film strip. If you've ever used web page tests, you'll see that you'll get a nice film strip of the test of what the site actually looked like with timestamps. You can even integrate I've seen some companies try to integrate AI into kind of capturing some new metrics, and you can do a lot with this. A lot of the third parties that, for example, like SpeedCurve, they actually base their technology on web page tests. And actually, it's an open source program, web page test, but they actually contribute to the open source project because a lot of these tools are based on open source technology. Again, the value add for something like SpeedCurve or even Lighthouse, although that's free as well, is the visualization. And so we won't cover visualizations here. but we're going to focus on capturing the measurements. And so the core of this talk will be real user monitoring, and it is what it sounds like. You are monitoring users in real life. Usually you have a throttle so that you're not monitoring all your users. You probably want some A/B testing framework to test, hey, this is a performance optimization I made. Let me compare it to, in an A/B test to a control group. And the metrics for this we will cover. Tools, we mentioned some, speed curve, calibrate, but all of those tools, at some point they use the APIs I'm going to cover, and that's what I mean by native. These are APIs at the browser level. Excuse me. And so a quick. So now that we kind of have a vague understanding about what I mean by performance, and I say vague because we could dive into the topics that I've already talked to in their own talks. But now that we kind of know, hey, we want to measure UX essentially. Let's have performance be a stand-in for UX. Let's say. Well, what does that mean? What do we want to measure? What goals do we want to add? And I think if you're looking for goals and don't know where to start, the Rail performance model, which stands for response, animation, idle, and load, is a great place to start. If your app meets the guidelines for the Rail performance model, you probably have a nice, a very performant app. And so let's talk about some of the goals of the model. Response to user input in under 100 milliseconds. That means if I click on something or I type, I don't perceive an interruption if it's under 100 milliseconds. It gets a little tricky because let's say you have an autocomplete component, and let's say for the sake of this talk, it's all done on the front end, so you have all the data, there's no fetching to the back end. If the rendering of the results is more than 50 milliseconds, then every time you type, you're kicking off, let's call it 70 milliseconds of work. Then you start building up, you start accruing that lag, right? About 20 milliseconds per character. And over time, the user will notice, because over time you've hit more than the 50 milliseconds that you should allot for. That's actually the maximum you should allot for doing a unit of work that represents a UI update, for example. So you want to ensure that any unit of work you're doing in response to user input is in 50 millisecond chunks, so that when you're building them at most 50 milliseconds, if you're under 50 milliseconds, then you don't have anything to worry about. That way, when they start building up, they basically are within that 100 millisecond time frame, and the user won't perceive any performance hiccups. And then for animation, you want to, especially if you're doing JavaScript animations with something like request animation frame, you want to make sure that your frame, the work you do to ship a frame, is under 10 milliseconds when animating or scrolling. And if you're into gaming, you know that for gaming you want to hit at least 50 frames per second. If you do the math there, it actually works out to be 60 milliseconds. So what happens to that extra 6 seconds? Why did we lose that 6 seconds? Well, the browser actually needs 6 seconds to render a frame. So what can happen is if you have a lot more work, you have more than 10 milliseconds of work to get your animation going, the animation will start to hiccup, especially if it's long running. Those 6 milliseconds add up, and it'll look kind of janky. The longer your frame, and for the most part, it's imperceptible. If you're within this range, you're fine. But if you have a multiple of that, then you're going to start seeing some lag in your application. And the next one, by idle, I mentioned it above. But basically, you want to make sure that the work you're doing while your browser is idle, while your main thread's idle, is within 50 milliseconds. That way, if user input comes in, and let's say you optimize your user input handler, but you're doing something in the background that is clogging up the main thread, there's going to be lag because the input won't be handled until that background task, I guess, is done. Not background, but that thing you're doing in the background has finished. So that's what the idle in this model means. It's just make sure to chunk your work. You're never doing anything that is more than about 50 milliseconds. Okay, and then load. Load, you want to load your assets and you want to get something on the screen in under 5 seconds. And that's actually for mobile. That's their mobile recommendation. I think for desktop, a second of load time is a good goal. That's what people expect. Mobile, there's a little more leniency. And with load, it's not just load, right? Because we're talking about perceived performance. Someone is not going to perceive your application as loaded just because it downloaded all the assets it needs. If there's a blank page because you're doing some processing, then that means that the user is going to think you're still loading. As a part of loading, it's also about optimizing the critical rendering path, and that's that starts when that request comes in for the HTML. It starts parsing the HTML, turns your HTML into the DOM, turns your CSS into the CSS OM. So if you're not familiar, it's a CSS object model. And those two are combined to form the render tree, and then we can calculate layout and so on and so on. And so if you meet the Rail performance guidelines, you're going to be in good shape if you hit these goals. And if you want more information, I've included a link to a good article from Google. It's their model, so check that out. And so now that we have kind of a guiding, let's start measuring. Let's see if we are meeting these guidelines. And so we're going to be using the Performance Timeline 2 API. It includes these entries, and these entries represent different measurements. Excuse me. They represent different measurements we can capture, and the big part of the API, the thing that makes it so lovely versus what we had in the past, is that we can now have now have this performance observer object that we can essentially use to observe performance measurements asynchronously. So before, you kind of had to do essentially some polling. You have to get performance entries and see what was going on. Now we can get them asynchronously through a callback, and the callback essentially gets fired when the browser's idle. There's some buffering that you can apply so that, I think it's 150 elements in the, and we'll see by what I mean by entries, and there's 158 entries you can limit it to. That way you're not clogging up. It's asynchronous, but you can still have a performance bottleneck if you're producing a lot of events. So you can have a limiter on that. And we will see this in action next in some demos. So the first one I wanted to start with really hammers home why performance is a perceived is really a perceived thing, not necessarily something the user experience. Just measuring and making sure everything is right is not enough. You have to kind of really capture the user experience. So this first measurement is not, I don't like to think about it as a real performance measurement in terms of timing. You want to measure things, as we saw before, we had goals that were all related to timing. This is actually really a perceived thing. If, and I'll show this in the demo, if your score is in this poor range, and we'll really see what this means. Your app can load quickly, you can meet all the rail performance goals, but your app can still look like it's janky and underperforming because stuff is going to flash in. And so what this measurement tries to measure is if you have let's say you load a landing page, a marketing site, a marketing page, and on the marketing page you have a hero image. If you don't set the hero image's height, for example, and when it loads, it pushes the content down, depending on the severity of that, you can have a really detrimental user experience. Like I'm reading something, I'm going to click on a call to action, that thing comes down, and I'm like, I'm done with this. They don't know what they're doing. They're not optimizing the user experience. And so, let me go back. So I'm going to show a demo of that. That was pretty fast, but I'll load it again. Notice how this ad pushed the content down, and it received a score of 15, of 0.15, I should say. And that score the big takeaway with that score is things below 0.1 are good. Things in the middle between 0.1 and 0.25, you could probably improve. And above 0.25, you have a very janky looking experience. And I can show that really quickly by increasing the height of this quote unquote ad. So I'll save that, and bam, I was reading something, I was gonna type in the input, and bam, it went away. So I'm like, this is a junk site. And so as we can see, the initial score was a 0.15, and now we're all the way up to a 0.4, 0.5 basically. You don't want to be there. Just to show, I'll show the code one more time. So obviously, I'm using a set timeout to display this ad, trying to mock like it coming from an API or something. But I instantiate a performance observer, and all I'm doing is I'm logging to the console the value. But I could send this off to Google Analytics or some logging mechanism that I have in place. And we'll get to how to do that efficiently as well. And so I instantiate my performance observer, and then I tell it to watch for something specifically. I tell it to watch for layout shifts. And if there's multiple layout shifts, I will, I'm just cumulative, I'm just adding them. But at any given, for this example, there's only one layout shift, one massive layout shift. And so what you do, this calculation here is not a part of it. You can set this up a little differently depending on your layout and how your app is structured. But the big takeaway is, hey, observe layout shifts, and that's it, you're done. You get this ratio handed to you, and you can see how severe your layout shifts are. And that's kind of the theme, right? The theme is watch out for this stuff and alert me, essentially, or tell me when you have a value for this thing I'm trying to watch. And then you can do whatever you want with it. And so next we're going to look at another example. This one is input delay. And so this one is directly tied to the model that I described. You want to make sure your input is not interrupted. And so in this example, I'm going to run it one more time. So here, I actually let it load for a while, and then I was reading, for example, and then I go to click on the submit button, and there was a 500 millisecond delay. I'm mocking that by adding DOM elements, random DOM elements. But let's say you have a form or something, and there's stuff rendering below, maybe a news feed or something, and you're rendering a bunch of stuff. While you're rendering that stuff, if you're rendering that stuff while the user is trying to interact with an element, then you could delay their experience. You could delay the input actually being handled. So first input delay is very important when a user lands on your site and you have a call to action right at the top, right? You have a hero section and a call to action. If your first input delay is slow because you're still processing DOM elements or doing whatever, the user's going to be like, well, I'm not even going to sign up for your thing, or I'm not even going to click on this button, nothing's happening, and you have a bounce. This actually, I'm adding, I think, 100,000 DOM elements. So this one's really severe. If the user goes to submit right away, you'll notice that it's 2 seconds, 2.6 seconds there. And again, this is mocking, doing some stuff, some computationally intensive stuff while the user's trying to do it. And so the key takeaway here is to capture first input, specifically first input. You just again instantiated a performance observer. Tell it right here to observe first input, and that's it. You can get that information, log it. If the user, for example, clicks on it, I'll let it. Maybe I can. Yeah, I'll do this. I'll render less items. If it's fast, right, then first input delay is, it's very fast. There's no delay essentially. We're looking at 2 milliseconds. Right, and so let's go back here. So that's first input delay. And this one I really like, but it's still in the it's still not ready for prime time. I think Chrome is the only browser that supports it. But there's polyfills for this sort of thing, and I've been doing them for a while. You know, I have this widget, for example, on this page that I want to know when it actually gets rendered to the screen. You would have to jump a little bit through hoops to be able to observe that. Now you can just tell the browser, hey, let me know when this element shows up on the screen. And so we'll look at a quick demo of that as well. So I add an artificial delay, but we notice here that the element showed up after 400 milliseconds. But not only that, we actually get quite a bit of information about the element. And the way you do this, it's a little more complex, but not that much than the examples I've showed previously. But again, we instantiate a performance observer. You know, we tell it, hey, observe for elements by using the type element. And then in our HTML, we add this special attribute where we give it an element timing. It's an element timing attribute. We give that element timing attribute a name, and essentially when it gets rendered, the browser will kick off this callback and pass it entries of this type. And again, we get a lot of information in here. Essentially the element and some timing information and some intersection, which is cool. If you've ever used the intersection observer, which is a different API, that's the API you would use today to do something like this, to make sure that it's within a certain bounds. And for us, it's it was rendered. So this is a really cool one. Again, I wouldn't use it in production if you're expecting to. It actually shouldn't hurt at all to use it in production. There's nothing really detrimental in terms of the performance. You should check whether or not performance observers are supported in the browser you're targeting. But in terms of it is supported, if performance observers are supported, but the element type is not, it'll complain. But that's about it. It won't break your application, or shouldn't break your application. So what else can we do? And this is probably the most powerful API, or I should say, measurement that you can get, because it's the most extensible. This is the custom measurements. Really important for real user monitoring. If you have certain interactions that you are afraid are underperforming, and you literally have JavaScript that you want to measure, you need to have some custom code. Unfortunately, you have to have some custom code in your JavaScript function, for example, as we'll see in this example, to get this measurements. But the good thing is that, again, they don't harm performance themselves. You know, they run essentially in constant time, and you get to see if there's regressions, or if you get to see if, you know, at scale, you know, how well do certain functions or operations scale. So we're going to look at another example for that. So in this example, I am rendering, and there's actually a couple things that's happening. There are a couple things happening here that we're going to get into, but I'm going to do a quick demo. So we noticed that this animation is pretty slow, and you know, it shouldn't be. You know, I tested it. What's happening? You know, I tested it with 1,000 elements. Why is it slow? Well, you know, the user has a state where they're rendering 20,000 elements, really 40,000 elements for this example. But because I observed it and I logged it to, and I apologize, I have to get rid of something from Zoom. There we go. Because I observed that and I got an alert, let's say, I can see that, you know, this animation's taking 600 milliseconds, which is unacceptable and actually affects the performance of the animation. I'll minimize, I'll clear this and show it. It's not a smooth animation at all. So what's going on? Oh, well, there's a lot of elements, so I'm going to artificially limit the number of elements here But let's say I would add some pagination if I'm rendering a huge table or something. I'm going to reduce the number of elements by an order of magnitude. And let's see what this does for animation. Oh, that's nice. That's nice and smooth, actually. Show it one more time. It's nice and cool. And I got all these animations. I'll show the links to all this stuff. I got this, I just searched for cool call to action. But we now notice that we improve the performance essentially to threefold. But there's a couple things here. We're actually, if we look at the code here, I'm setting a timeout of 200 milliseconds, and I know that actually should be close to the upper limit of this animation. So I know I have a bug somewhere, and the bug is this right here. This actually is an example of a bug I found a long time ago, where there was a bad merge. I'm guessing, where they were using this offset height to do some calculation, and then they got rid of it because it was underperforming. But they left this artifact in here, and this artifact, as we'll see, has performance implications. In this case, they're not terrible, but still, why have code that does nothing that hurts performance? So now we got our, if you look at here, we have our animation running at, after 248 milliseconds. Now we got it to close to 200. Why that performance improvement? Well, that, let's see if I can get it back. This actually, what this does is it tells, it goes and reads the DOM and says, hey, give me the offset height of this element. And what the browser has to do to get that value is actually calculate that on the fly. It doesn't store it in memory. The reason being is that it needs to have an updated picture of the layout and styles on the page, so that if you scroll or if you take an action that changes the UI, it can calculate that quickly. So it calculates this and a bunch of other properties on element. This is called a reflow because we actually triggered a layout calculation. That's what this specifically does. So I'm going to get rid of it. It's an artifact. I don't need it. And we'll look at the performance observer for this as well. But another cool thing that we're doing here is I'm artificially, actually adding all these random elements to the page. But I'm trying to even do that efficiently. There's a nice little, and again, this is evergreen technology, so make sure to look at the browser support. Make sure it's supported in the browser that you're targeting, the browsers that you're targeting, I should say. But request idle callback. We mentioned before about trying to do work when the browser is idle. When the browser is idle, is that nothing's going on essentially. There's nothing computationally intensive. The browser is not calculating layout or painting. It's just sitting there. So when this example loads, it first generates 2,000 elements in one of my divs. It adds 2,000 children, and then I try to get a little cute and I add this request idle callback. And what this does is it waits until the browser is idle to call this callback. There's polyfills with set timeout. And those are inefficient because those are time-based. You're literally running the code after after the browser is idle, but basically after a set amount of time. But with this, you get true, hey, when it's idle. If, for example, you shouldn't rely on this to do things that are important. You want to rely on this to do idle work, background work, essentially. If you are doing a lot of things on initial render, if you're clogging up your critical rendering path, then, for example, with JavaScript, then you want to make sure to add a timeout option to this to ensure that if the browser isn't idle, in this case after 2 seconds, call the callback. Ensure that it gets called, because actually this is kind of important. But if it's idle after a second, call it back then. And so that's what's going on there. But let's look at now the performance observer example. And in this case, I'm really just watching for measurement. And we'll look at what that looks like in the code. So here, at the beginning of the stuff I want to measure, I give a mark. I call performance dot mark, and I say, hey, mark this somewhere, essentially, as the beginning of my measurement. And then over here, after this final action is taken, hey, that's the end of my measurement. And then you call measure, and you give this measurement a name so that you can find it easily. But basically, this measurement is composed of the start, which is animation, which I called animation start, and this this animation end. So in between, capture the timing at animation start, capture the timing at animation end, and give me measurements between these 2 points. If you misspell, you get a warning, you get an error. So just make sure that you call these, these are set up appropriately. Again, this gets into actually modifying your code to capture measurements. I would do this in A/B testing. I wouldn't put this out to everybody. Put in a control with a control size. But this is very useful, and I'll show more uses for this in a bit. But again, it's to capture custom measurements that aren't necessarily represented in the timing APIs that we have already looked at. So that's this example. And please tell me to slow down if I'm rushing through. We covered custom measurements. We can use this and mark and measure API to actually capture blocking style sheets, blocking CSS, and blocking JavaScript. And something like this is kind of how, if you remember the graph that I showed earlier, kind of how that is captured. So we'll see an example of that. And so I have some script tags, and again, with mark and measure, be mindful of where you're putting this. I wouldn't recommend putting this all over the place because it'll bloat your HTML. But if you want to do some quick measurements of, for example, blocking CSS and blocking JavaScript, you can do something like this, where at the beginning of your tags, right before your tags, you declare a start, you declare an end after, and I did the same thing. Well, there's a lot of HTML in this example, but I did the same thing for my JavaScript, and we'll get an actual measurement of how much time was spent essentially building, downloading, parsing, and building that CSS object model that we talked about for these particular style sheets. And it took 300 milliseconds. And so could you inline some of the CSS? Could you cut out some of the CSS? Just a quick test of that. Let's see if we cut out Bootstrap. We actually only use Bootstrap for a very limited amount of things on this page. So let's see what cutting out Bootstrap does for us. And it cut out 200 milliseconds. There you go. Inline the Bootstrap stuff that you actually use, keep everything else out, and you'll have a nice performance boost. And again, we'll see that the JavaScript for this looks fairly similar. You're declaring a performance observer, and you're observing measurements. For this particular case, I'm just polling. So this is how you would get measurements after the fact. You would call performance get entries by type, and I know I want measurements. And that allows me to synchronously, essentially, get the information I want. So in case you want to do this synchronously. But again, try to use the performance observer wherever you can. Oh yeah, that's this example. Already went through that. Let me present. Right. And so let's say you've collected all the measurements you've wanted to collect. and you want to maximize the user, you don't want to hurt the user experience so much so that you're going to send all your information on when the user's closing your tab. For example, they're on a tab, they close the tab, and you want to send that information there. And this was common practice for years. Excuse me. This was common practice where you want to capture key things. You don't want to keep sending requests every time you capture something. You don't want to build a complicated queuing mechanism. You just want to send as much information on when the user is essentially done with your user experience, right? They're closing your tab, and the unload event is firing. Why don't you send some information there? Well, what people quickly figured out was that you can't actually send an asynchronous request, and that you can't do an asynchronous AJAX call in the unload event. If you try to do this asynchronously, it won't get fired. So what you have to do is with this flag over here at the end. Oh, sorry about that. With this flag at the end, you essentially set it to false, and it says, "Hey, make this request synchronous." What that means is, if you're sending a lot of data, and for whatever reason it's taking a while to actually send that data, the user will be blocked from closing your tab. And although your user experience is done, right? Your application, the life cycle of your application is done. They've stopped consuming it. They're closing the tab. You're still hurting your user, and they will remember that. Hey, this thing always is so slow to close. So in order to avoid that, I think Chrome, Google really hammered this because they have Google Analytics, really pushed this API forward, if I remember correctly. There's a new API, and it works like a post. So if you do a post, do a post like up here, it just this post, and it allows you to do a post request to your logging mechanism, but it won't block. It will do it asynchronously, and it won't block the unload event. That's the big innovation there, meaning that and it'll actually run in the background. You'll close the browser. It'll close. Let's say you close the browser, and this event fires. It'll actually close normally, and Chrome will make sure to fire it. You don't get much information though from this API. You don't get whether or not the call was successful. This is because the way they managed to ensure that it's asynchronous on the unload event is that this call is done in a different scope. So you can't actually get information from this call. All that navigator.sendBeacon returns is whether or not it was queued up, not whether or not it was successful. So that's just something to keep in mind. It's kind of set it and forget it. And so now that we've covered some measurements, now that we've talked about some goals with the Rail model, and we have a nice and snappy way to send information to our analytics provider, let's cover some basic optimization. So the goal of this talk was to see what's the minimum thing you could start doing today to start capturing and improving your capturing performance measurements, and to also improve performance. If you read the follow-up articles that I'm going to share at the end, you'll see that it's actually pretty involved to improve the performance of your application. It's not an overnight thing, but thankfully there are some quick wins you can implement today to get some performance improvements, and we're going to start looking at those next. So the next, the first optimization that I want to talk about is resource hints. And so I think you've probably seen these. They're usually a link tag with a rel attribute that is this funky rel attribute that you might not know off the top of your head what it does, but you probably get a feeling because the name is semantic. And so we're going to cover these quickly, but the first one is the pre-connect hint, and it tells your browser to do the connection step of the request, as soon as it sees this hint, versus when it's actually requested by your JavaScript or by your HTML down the line. And so what that does is, the picture actually does a really good job of explaining it. If your requests for assets, for example, are done like this, right, the connection step will take place when you make the request. And then it will download and you will get back to your resource. Then it will download. You know, there is some parallelization of connections, but why not tell it to do all the connection steps? You know you're going to hit these domains for resources. Why not do all the connections up front? And so you're essentially parallelizing them, and then your requests are a little shorter, right? And if you have a lot of these connections, then the savings will really show up. If you don't, then you're still getting, you know, small benefit, but no real downside, right? So why not do it? And similar to the pre-connect resource, we have the DNS prefetch. It essentially does the same thing as the connection step, except for the DNS lookup step, and it runs those ahead of time so that your requests are a little faster. Then we get to some more serious resource hints. We have the fetch resources, the prefetch hint, and it fetches resources and stores them in a cache. And this is meant to be used in a future navigation, right? You have a page, you know, you have a landing page, a marketing site, and you land on the home screen, and you know you're going to push people towards your big selling your selling screen. So why not prefetch some of the resources that page is going to need, so when the user navigates to that, things load even faster. Similar to the prefetch hint, there's the preload, and that is essentially the same thing, except it's meant for the current navigation. So if you're the current page you're on, I should say. So for example, you're gonna download an image. You know, you have, let's say, a React application, and you know it's going to eventually render a widget that downloads an image. Why not, for example, prefetch that so that, you know, it kind of to the user it looks like it loaded pretty quickly. And the last one is experimental. Excuse me, I'm going to take a sip. But the pre-render, this one's a little dangerous. It's still evergreen, so just experiment with it. The specification is not fully fleshed out. Most browsers support it under a flag, so you won't even be able to, you know, be able to use it without a flag. But this one's interesting because it's again a hint, and what it does is it tells the browser to render the entire page in the background. So let's say you've got, you know, that same marketing example, you have a pricing page, I should say, and you know that's the next thing you're going to direct people towards after they land on your home page. You know, you could theoretically have the browser pre-render that with this hint. Again, that you know, that is blocking. That will block the main thread if it's a heavy JavaScript application. So this one's still in the experimental stage, but again, it's native, meaning all you have to do is add these link tags with the appropriate rel attributes, and you get these benefits today. Very minimal amount of work. The next, and we actually talked about another optimization, the request animation, the request idle callback. That's actually useful for optimizations. But now we have, you know, a really, you know, it's a lazy loading of images, and it's very, you know, very simple to implement. You just essentially, well, that's not the whole picture. We'll get to why that is in a second, but we have this this attribute loading lazy that we can add to our image or our iframe, and it will load it lazily. And what does that mean? Let's go. And there's this article that goes in depth. I suggest you check it out. So I have this demo. We have these cat pictures, about 100 or so. I'm going to disable caching, and I'm going to do some setup here. I'm going to pretend this is a mobile app, mobile website, and I'm going to go on 3G speed, fast 3G. And I'm going to refresh, and we're going to take a look at how long this takes, because we're downloading all 100 images at a time. And so we saw that it's still going, it's still downloading. Not great for the user's data if they're on mobile, right? And they have a limited plan. And there we go. We downloaded 2 megabytes of images, and I'm only going to scroll halfway, so I didn't need to download all the images to provide a good user experience for me. You might be different. You might want to look at all the cat pictures, but I only need to look at about 50. So we're going to now look at this. And you notice that it loaded faster. And the reason that it loaded faster is because we're just sending less requests. We're sending less requests for images. And you'll notice that as I scroll, I should probably be on this tab. This would be more useful. I'll refresh one more time so that we see, oh, I was halfway. So let me scroll to the top and refresh one more time. So we noticed that we kicked off about, I would say like 12, 15 requests for images. We'll get to why that many, but I didn't do all of them, right? And we'll notice that as I scroll, they start loading, and from a user experience perspective, it looks uninterrupted to me. I could scroll really fast and try to get to the threshold, but as we can see here, on a fast 3G connection, it's a pretty good user experience, and I'm only downloading what I need. If I stop here, you know, I only downloaded 1.5 megabytes of cat pictures. I'm done. I got my value. I can leave, and my data plan won't. You know, I didn't exhaust my data. So what's happening here? The browser is actually setting a threshold. You don't have access to the threshold. You don't know what it is. I think some people have done experiments to kind of guess what it is. I think on Chrome, it's about 5,000 pixels below, 5,000 pixels from the top of the viewport, I'm guessing. Again, it's a guess from experimentation. And they might change it. But whatever the threshold is, if you have a lot of images or for some reason a lot of iframes, if or you have an article, right, that has a widget that's loaded in an iframe, the user only loads the top half, they never reach the threshold, that iframe never gets loaded and you're saving your user data. And also if the iframe, for example, kicks off, you know, iframes on different domains are isolated, so it won't be too much of a performance hit, but you know, on mobile, it probably will be noticeable. Why not prevent that stuff from even firing off those requests when your user doesn't get any value from it? And again, it's essentially, for the most part, a attribute away. A couple caveats with this. This is a relatively new API. It's in the current implementation of Chrome, it requires your image response. It requires your server, I should say, to have the range header. So from my understanding of the implementation, Chrome will send off a preliminary request for the image to get a certain information about that image so that it can do some optimizations. So essentially it is kicking off requests, but they're a lot smaller, right? If the user never loads the images, then it's a net, never loads all the images, then it's probably a net win. If the user loads all the images, then essentially you have a couple more requests, but substantially, it's of no substance. They're very small. They might change that implementation in the future. What it could look like, and I believe the article that I linked to in this slide goes into more detail. What it could look like if your server or your image CDN does not support this this range header is double. You actually have double the request, right? Because Chrome does that request, it actually gets back all the image information, and then it'll fire off a second request when you actually scroll and hit that threshold. So just be mindful. Again, it should be minimal amount of work, and if you're using an image CDN, most of them support it. So just be mindful of that. But again, if it does support it, then it's very simple, very easy work, and you could have a lot of upside, and your users will thank you if they're on mobile and they're on a limited data plan. And that is pretty much the crux of the talk. There's some further reading you can do. These are actually all case studies and posts by Adi Azamani. He's an engineering manager on the Chrome team. If you're familiar with front-end development over the last 10 years, you've probably run into his work. He's obviously contributed to Chrome, but he's very instrumental in the design of jQuery back in the day. A lot of the patterns that are still followed today in JavaScript are owed to Audi and people like Paul Irish. So these case studies in particular, some are for Pinterest, some are for Chrome. I'm sorry, some are for Netflix. Take those, go deep dive into non-native optimizations, actual work. They go into React in a bit of detail. So if you're interested, if your stack has React in it, take a look at those. But again, that's pretty much the crux of the talk. Next, and excuse me if I bumble this, next we're going to do a little quiz to win a prize. If you've been paying attention, then it should be pretty straightforward. So if you do me the favor, let me actually, yeah, you do me the favor, a favor of navigating to this URL, www.kahoot.it.com. I don't think we're gonna have time to download apps. And when prompted, put in this PIN. I'll actually wait until players start registering.
And just so everyone knows while we're waiting, everyone knows what we're playing for is the Apple AirPods, and it will also be for the Facebook device, the camera and video. So
cool. So I'll give it, I'll look at how many people are left in the Zoom, and once we have a good number, we'll start. Try to use Chrome. I know that there were issues on Edge with this app. So if you're on Edge, please use that. I think every other browser should be fine, but just so everybody's aware. It's only 7 questions, so 10 seconds apiece, so it won't be too bad. I see a good amount of people. I'll leave it open. I'll start in a bit. Let me just check. Well, what's the number? Okay, I'm gonna go ahead and start. So it should be loading. Please let me know if you don't see these questions. So this first question is a practice round. Oh, so this one's 20 seconds. I think that the following questions should be 10 seconds. What's the company that I work for? Well, we'll let the time pass and we'll see what that looks like. And so everybody got that correct. Again, if you didn't make it in, I left it open, so you should be able to join us. Okay, so we're going to go to the next question. So be on your mark. Question 2. Which performance monitoring approach is best suited for catching regressions before deployment? So if you want to catch stuff before you deploy to production, what approach would be best? And that is the correct answer, synthetic monitoring. So we're going to go to the next one. Which approach is best suited for capturing the average first input delay experienced by users in Nigeria, for example? What approach would be best suited for capturing real user data? Cool. We're going to go to the next. You'll see that this changes. Time is also taken into account. So if there's a tie, the tiebreaker is time. So just be aware of that. Pre-connect, DNS prefetch, prefetch, preload, and pre-render are examples of resource hints, performance entry types. Cool. So leaderboard has shifted a little bit. Let's go on to the next one. Which of these needs to be in the response of a resource request to enable performance resource timing? Oh, this one, This one, if you guess, I'm going to skip this one. I'm going to skip this one because I didn't actually get to talk about this. So I'm going to skip it. It's a wash for that one. I apologize. I forgot that I wanted to throw that in there, but we didn't get to it. So we're going to go to the next question. True, false. Web page test is an open source tool for enabling RUM. Is this true or is this false? Talked about it a bit. The answer is false. It's for synthetic. For synthetic, yeah. Not RUM. Cool. The DOM and CSS are combined to create the critical rendering path, render tree, DC or page layout. What does it immediately create once we have it? And the answer is the render tree. Yes. And the render tree then triggers layout. So they're related, but immediately after those two are calculated, I should say created, you have the render trees created. Cool. Oh, this is exciting. We have shifts. Okay. Last part, calling. Oh, we're going to, we're going to skip this one. I apologize. I thought I updated this. I apologize. The answer is layout. The answer is layout. So I'm going to look at these. So in first place, we have wells, and I'll take a look at these just to make sure, everything's fair. I apologize. I updated this right before with some modified questions, and it obviously did not take, and I apologize for that. Cool. And so at this point, we could move over to Q&A. If you have any questions for me, feel free to ask. I will go to the beginning.
If anyone has questions, sorry, I was just going to say, you can drop them in. We can kind of hang out for a few minutes just in case there's any straggling questions. There's a Q&A function kind of built right into Zoom that folks can use, or the chat works as well. And I guess just to seed things real quick, you talked a lot about, I knew you going through the performance APIs and a lot of like how you can sort of roll your own, monitoring of these sorts of things. And you talked about, using A/B testing to do sampling and stuff like that. I'd be curious to know if you had any, particular go-tos when it comes to actual RUM tools, and a little bit of like where do you personally draw the line of like, what's between rolling your own versus all the, going with a full-on RUM product that gives you all the different facets like country of origin or device type or any of the other stuff where it would start to get really cumbersome to do it yourself.
Right. And so what's interesting about performance monitoring specifically is if you look at all the RUM tools, you could look at Lux for under a speed curve. They're just a thin wrapper around the APIs. So the actual calls to their products in your app, especially if you're doing real user monitoring, look fairly similar to the APIs that I showed. Now, what they allow you to do is on top of that, within that thin wrapper, they have controls for A/B testing so that not everybody's in the sample, for example, for a particular test. And so for everybody else, that is essentially no opcode that does nothing. But for people within the test, it actually does something and actually collects the data. My go-tos for RUM are speed curve because I think they have the best visualizations. Calibrate is close, but speed curve has been around for a while. It was founded by the chief performance Yahoo at Yahoo, he's called Steve Saunders, I believe is his name. And I'll look that up and add that to the slides. He's known as the godfather of performance. He's built and helped a lot of the tooling He's contributed to web page test himself. Was a big proponent of getting Lighthouse built into the browser. So when I really trust him, and so I trust his product, and I've used his product. But use whatever you feel more comfortable with. Do your research. There's a lot of tools out there, but again, SpeedCurve is probably the oldest, and personally for me has the nice visuals that I like, that you're paying for, right? That other stuff that you mentioned, I'm not sure that it's necessarily included in SpeedCurve. I know it's not. You have to log that stuff yourself somewhere else. You have to turn that on essentially. But yeah, I would look at SpeedCurve personally. I really enjoy it. Web page tests for synthetic, start there. That's what everybody basically bases their stuff on. There's other tools that use other underlying tools, but you can't go wrong with web page tests and SpeedCurve is what I find. Hope that answered your question.
Yeah, absolutely. I'm always just interested to see what other folks do. I'm a monitoring and performance junkie myself, and have tried most tools under the sun. So it's just and I've also fought that battle plenty of times of rolling my own versus using a service and all that sort of stuff.
Right. So that's a nice thing about with SpeedCurve or some of these other products, you don't have to instantiate performance observers yourself. That's a nice one. But if you want to start experimenting today and you have some logging mechanism, these tools are relatively inexpensive, depending on the size of your company. I think SpeedCurve is something like 18 grand a year, which is kind of standard for these monitoring things. So if you want to start playing around with it, show, for example, a proof of concept, start, seeing where regressions are before you commit to a paid product, definitely use some of the stuff I showed here today.
Yeah, absolutely. And I could also just add another vote in general for the importance of measuring this stuff at all. I think a lot of folks, rest a little bit too easy sometimes on your own testing and testing in your browser in ideal conditions, or even with the network conditioner type settings in Chrome, when ultimately the only data that really matters is how actual users out in the wild are perceiving things, and being able to get that data, even simple data points coming from real users of all the different cohorts that you can, is just super powerful.
It's super powerful. You get device data more accurately in the wild. You get network data out in the wild. I didn't even show the resource timing and the navigation timing APIs but you can actually get really in depth with this stuff. And yeah, like you mentioned, essentially when you're testing the performance of something in your browser, you effectively are running a manual synthetic test. You're under control settings. You're probably in an office or in your house with great network conditions. If you're running the test with your server running locally, then essentially the network is not even a thing. So yeah, I think, like you mentioned, people have been content with, running these local tests, looking at, the performance tab, and just, moving forward. And then, a couple weeks down the line, after a feature is out in the wild, and people are using it under heavy load, or people are using it with lots of data, you've hit that limit, and you're like, wait, I tested this. And it's like, well, no, you did not. Not under all conditions. And so you could do, again, synthetic testing to try to cover all that. But I suggest as you want to be light, you don't want to have you don't want your code to just look like 90% measurements, right? You want to use it sparingly, but intelligently. You want to say, hey, this is an experiment I want to run. Let me put this out, and eventually sunset the experiments once you have the data, right, that you need.
Yep. Awesome. So we don't have any other questions lined up that I can see, so I won't make you stick around. But Joel, this was a fantastic presentation, and we'll get the video up on our channel within the next day or two once it processes, and send that link and the slides and any content that you have out. But again, Joel and everyone at ServiceTitan, I really appreciate being willing to do this and hanging out tonight.
Thanks everybody, and thank you for putting up with my questions. This went smoothly up until the end. I thought I got those updated, so I apologize for that.
Awesome. And thanks as always for everyone for attending and hanging out, and we'll hope to see you soon. Stay safe.
Bye, everybody.